Okay, so welcome to this session of where we'll be solving some problems. Um, we'll be talking about the cyberspace mass contest that was just concluded recently, and I'll be talking about the geometry of the first day. I think it was an interesting problem, so let's go to that. Okay. So here the problem says let ABC be a triangle such that AB is greater than BC, and let D be a variable point on the line segment BC. Let E be the point on the circumcircle of triangle ABC, lying on the opposite side of BC from A, such that BAE is equal to DAC. Let I be the center of triangle ABD, and let J be the center of triangle ACE. Prove that the line IJ passes through a fixed point that is independent of D. Okay, so let's go straight into this question. So how I'll introduce the point F. So how I define the point F is this. So F is the intersection point of circumcircles of triangle AID and triangle AJC. Okay. So before we start, let's just denote some angles. So let's call this angle here B. That is angle the usual denotation of angles in a triangle in geometry. So let's call this angle here B, and let's call this angle here alpha. So this angle here is also alpha. Okay. So the first claim from this is so let me just write in a different color. So the first claim is that I, J, and F are collinear. So that's the first claim. So let us keep it in red, in black rather. Okay, so how do we do that? So now let's look at triangle. So in triangle ABD and AEC, what can we say? First of all, we can see that angle ABD is going to be B. Now angle AEC is also B. Why? Angle subtended by AC in the circumcircle of triangle ABC. So we have just a side note, angle ABD is equal to angle AEC. Now already we have that the two smaller angles, the smallest angles in the two triangles are equal. So that is by definition of points D and E. We have that BAE, which is equal to DAC by definition. So this is equivalent to saying so when we subtract angle DAE from both sides, so subtract DAE from both sides, angle DAE from both sides, we have that the angle BAD is equal to the angle EAC, so which I've already denoted as alpha alpha by the addition of the points. Okay, so that's cool. So let me just erase this because we're going to be working with a small space here. That's basically it. So let me just quickly put BAD equals to EAC. So BAD equals to EAC. So you can just see that immediately. Now, what does this imply? It implies that the third angles are equal. So it means that angle ADB is equal to angle ACE. Now, since the two angles are equal, it means if we take half of the two angles, so half of the angles will be equal. Now, half of this angle, since I lies on the angular bisector of each of the angles in the triangle ABD, similar thing for J and J in the triangle AEC and each of the angles therein. So we can see that this implies that ADI is equal to ACJ. Okay, so now let's look at ADI. So let me just draw a line using black. So we have this angle here, which is equal to this angle. Now, angle ADI from the circumcircle of AID is going to be equal to angle AFI. Now, and also similarly, angle ACJ from circumcircle of AJC. I will define point F from the beginning. So angles subtended by the chord AI and this one AJ and CJ. AJ rather, yeah. So this angle here is equal to angle AFJ. So let me just quickly mark that out. So what do we have? So we have this angle here is equal to both of them. So that's assuming they're not like straight lines. So it will be something like this. Let's say, so this is A, F, J, and then AFI. But this angle is also equal to this angle. So it means this small bit here is 0 degrees. So it means that the lines are collinear. The points are collinear rather. So yeah, we can conclude with that. Okay, so this claim is proved. So this implies IJF, that's this whole bit here, are collinear. Now the second claim, claim 2, let me also write it in black. The second claim Now we don't really know that B, D, C, F are collinear, so that the second claim is D, C, and F are collinear. Okay, so how do we do this? We use a similar fashion. So let's draw the angle bisector. So this angle here is alpha over 2 because of this the in-center, and the in-center by definition is the intersection point of all the angular bisectors of a triangle, or the interior angle bisector of the triangle. So this is also alpha over 2. Okay. So now in a similar fashion, we have that this angle here is alpha over 2. So we have that angle J F C equals to alpha over 2. And in similar fashion, from this bigger circle here, we have that this angle here is also alpha over 2. So angle IFT so equals to alpha over 2. So as before, in this other case, you can get that D, C, and F are collinear. Okay, so let's finish it off from here. So what is this angle here? Since this whole angle here is alpha, it means this angle here, sum of opposite interior angles as this angle plus this angle plus this angle. So using that idea, we have that this angle here is going to be B plus alpha. Okay, so it means this angle here will be 180 minus this, that is 180 minus B minus alpha, but then half of it. So let me use half of it is going to be what this angle is. So this angle here is going to be half of this. So we get that. Let me just quickly write it. This angle here is going to be 90 minus B over 2 minus alpha over 2. Okay, and then we have this angle here is alpha over 2. So it means this angle here will be this angle plus this angle minus 180. So let's find this angle. Let me use a different color. So basically we're just like done with it, just want to finish it off. So this black angle I just shaded is going to be 180 minus alpha over 2 plus 90 minus B over 2 minus alpha over 2. So if you do the math, that's equal to 90 plus B over 2. Okay, so we have that this angle is 90 plus B over 2. So it means this angle here is 180 minus this angle. So 180 minus B, this angle here is, the opposite angles of a circle collateral are supplementary. So that's 180 minus 90 plus B over 2. So which is 90 minus B over 2. So we have this angle is constant, and in fact, since this angle here is 90 minus B over 2, it means, okay, let me just do some erasing. Okay. Yeah, back. So it means since this angle here 90 minus b over 2, we can quickly get this angle here to be also 90 minus b over 2. So in fact, triangle ABF is isosceles. So as point D moves, BA is always equal to BF. So it means that F is the constant point that IJ passes through. So like this solves the problem. So we'll just do a little animation on GeoGebra to see this in action. Okay, so let's do this. Okay, so as you can see, as point D moves, it's always passing through point F. Yeah, so as you can see, it's always passing through point F. Okay, so we see that mass always works. So thank you guys. I know the video was longer than expected, and we'll discuss more about the cyberspace mass contest. I think the questions were pretty interesting, difficult, and yeah, I mean that's what the Olympiads are all about. So see you guys later. Bye. And please don't forget to subscribe, share, and tell your friends that there's actually a special Mass Academy on YouTube. Bye.